Now the next experiment in your semester 6 practical course, to study the UJT as a relaxation oscillator. UJT means a unijunction transistor, and it acts as or works as a relaxation oscillator. And by studying that, you will have to determine the frequency of UJT oscillator. That is the aim of our experiment. Alright. Now here, in order to study this characteristic, you will require a UJT. This is a symbol of UJT, emitter of the UJT, base 1, base 2. The circuit diagram is shown here. Now here you will get the output. Here you will get the channel 2 of the CRO you have to connect here. Channel 1 you will connect across the capacitor. You can see the waveform across the capacitor here. Resistance R, R2, R1. So here this is the circuit. Emitter B2, base 2, base 1. These are the two resistances connected. Here the variable resistance is connected as R. This is a capacitor C. Here it is capacitor C. Here you can measure the output voltage. So channel 2 is shown here. So you will get the output of the UJT relaxation oscillator circuit from here. Then 12. Here you can apply the 12 volt supply. So here by using this battery, here you can apply the 12 volt supply voltage. You can apply VBB. Now with this circuit connection, oscillator means what? Without application of any input signal, you are applying the DC voltages there in the circuit as a VBB. You will get the output signal, a sweep type of waveform, a rising sweep, decreasing sweep will be there in the waveform, and such type of waveforms you are obtaining, and therefore it is called as a relaxation oscillator. Now here in our experiment, first we will have to connect the circuit. In order to connect the circuit, this already connected circuit, solder circuit is given. 12 volt power supply you can connect here. Then across this variable resistance I will connect. Then you will have to connect channel 1 here across the capacitor. Channel 2 will connect to the output. So only few these circuit connections you will have to do in the experiment. Then by varying the resistance R, because capacitor you are keeping fixed, R you can vary. So you can vary this resistance R, and on the CRO you will be able to see the waveform across the capacitor and waveform, output waveform. So this will be the nature of the waveform which will be visible on the CRO. So you can see that. Now what will be the experimental work you have to do? R you will vary. So this resistance box is there. Now at presently it is 18,000 is the ohm is the resistance we have kept. What is the period? You can measure it on the CRO panel. So here it is shown in the diagram. You can see this will be the period, right? Measure it from the CRO, multiplied by the time based knob. Whatever will be the period that you have to enter here. Measured period. Take the reciprocal of that, you will get the frequency of UJT oscillator experimentally. Then theoretically also you can find out the formula for calculation of the period. It is given here. Of a UJT relaxation oscillator, the period you can find out by using this formula. Reciprocal of the period will give you the frequency. So like this way, by varying the resistance R, you will be getting the different output waveforms with the period. Period will change. Find out the corresponding frequencies. Compare it with the calculated frequency. You will find that the frequency depends upon the time constant RC and the UJT, but it is fairly independent of VBB and temperature. So that will be your result. These waveforms you will have to trace. As you will for first reading you will have these two waveforms. For second, third, fourth, 5. So 5 readings you will have to take. Corresponding waveform across the capacitor, output waveform. So like this way 10 waveforms totally you will have to trace, and these two tables you will have to compare. Calculated frequency of a UJT relaxation oscillator here you will get, and the measured or the experimental frequency you will get here. Compare that. You have studied unijunction transistor as a relaxation oscillator. So this is the in short procedure of the experiment. Now this is one of the semester 6 experiment you are having in your practical course.